Okay, so the basics of geometry. Euclid, some famous guy from back in the old days, came up with this kind of geometry, Euclidean geometry, based on his name. Okay, we start out by talking about points, lines, and planes. Okay, they're all undefined terms, and they're mostly imaginary. A point actually names a location, like over 2 and up 3, there's a location, okay? And it has no size, so even though I made a dot right there, that has size, doesn't it? Okay, well, a point doesn't have a size. It's just a location, which is kind of weird, but we still have to, if we want to represent it, we have to make a little dot. And whenever you talk about a point, then it has to be a capital letter, a block letter, something that's straight up and down, right? So like X, that could be a point, or Y, that could be a point as well. So it's a capital letter straight up and down. It's not cursive looking, okay? M, here's a point, okay? All right, so here, a line is something that goes in both directions forever. That's why they put the arrows on it. Like this really is just a segment, but if they put arrows on it, then it would be a line, okay? A line is straight, goes forever in both directions. There's no way you can draw a line, because a line, if you just kept drawing, it would keep going and going in both directions forever. You wouldn't, it never stops, right? So you have to imagine a line. You can't measure one. You don't know how to, because it never stops going. You could be doing it forever and you'd never be able to draw a line. Okay, and a line has no thickness. And it says it extends forever. Okay, if it has no thickness, which means you can't see it, but so you have to imagine it. Okay, so we've got lines here, and there's 2 ways to name them. Okay, there's 2 ways to name a line. Okay, one of them is this lowercase cursive letter. Cursive's kind of off to the side. You remember that? Okay, a cursive letter. So you would actually use the word line, L. Okay, now this L is not a point. Like X, Y, and Z are all points on the line, okay? L is just a different way to name this line, and you put it just off to the side, and so you actually use the word line L. But the second way to name a line is to use 2 of the points, okay? So I could say X, Y, and then I have to put something over the top to represent the line, but this is a segment. You have to put arrows on it before it becomes a line, okay? So X, Y is this whole line, right? I don't have to pick all 3. I can pick any 2 of these. I could pick, Y and Z, and that would work as well to represent this whole line, right? Because it goes forever in both directions. 2 points is enough. I could switch it around backwards, okay? And I could still represent the line. So YX still represents the whole line. Here's something I don't want you to do, though. I don't want you to say XYZ. Okay, there's only need for 2 points. Don't do this. Okay, let me go ahead and put a circle around and go, shh, don't do it. Don't do it, okay? Another thing I don't want you to do is use this like it's a point. Okay, so LX or whatever. That's no good either. Okay, so let's mark that out. So don't use that as a point. Okay, so either 2 points or use the cursive letter L with the word line. Okay, planes. Planes are flat surfaces like this sheet of paper. This table is a plane. It's a flat surface. Now, a plane has no thickness and extends forever. Once again, you have to imagine this flat surface just going way out every different direction, okay? So it's a 2-dimensional surface. Like a coordinate plane is a plane, okay? So is this one. They usually represent a plane by doing a parallelogram, and then they put points on the inside, or they put a capital cursive letter in the corner. So there's 2 ways to name this one too, okay? So one of them is to use the script capital letter or cursive capital letter. So you can say the word plane, and then you put the fancy looking R, which I don't think I'm going to be able to do a good job. So that's the fancy looking R. So in the corner, now that's not a point. There's no point next to it, right? It's just a capital cursive letter that's stuck in a corner so you can name it. Or you're going to use three points. Okay, so you can say plane ABC. Now, this can be hard to show because I usually do a visual in class. You have to use 3 points that are not in a row. Okay, see how that says this? It says the other way to do it is you have to use 3 points not in a straight line. Not in a straight line to name the plane. Okay, and are A, B, and C in a straight line? No. Okay, so that's a good name because that's a unique name. Let's see if I can do this. Okay. Okay, if I had 3 points in a row, A, B, and C like this, then there are a multitude of planes that I could put through those 3 points. Like that one straight up and down, okay? I could put one through at that angle, and then this angle, and then further, and I could go the other direction. And all of these planes are plane ABC. I could have an infinite number of planes that go through ABC. And so since it's not unique, then 3 points that are straight in a straight line are a bad way to name a plane. Okay, so we always look for 3 that are not in a line because there is only one plane that can have A, B, and C in it, and it's this flat plane right here. Okay, so it has to be unique. ABC is unique here. It wouldn't have been there. Okay, so anyway, we want to label these either a point line or a plane. These are examples that you would have done in class. But anyway, taut is when you're like have a string, you're holding a string, it's kind of loose, and you go bing and make it straight, right? If you make it real straight, then it's a taut piece of thread. So which one would that be? Yep, it would be a line. Okay, a knot in a piece of thread, that would be a point. Okay, a piece of cloth, I'm assuming they're saying flat on the ground, so that's a plane. Okay, pixels, you ever seen those on your TV or whatever, or your computer or whatever? There's a bunch of holes in the screen, and they're, each hole has color that comes out of it, and all of them mixed together will make a picture. And the more dots you have, the better screen you have. Okay, so of course those are points. And then the top of your desk is, of course, a plane. All right, so we've got this picture. Oh, okay, I just noticed an error. Okay, they're wanting to say that this is line M. It's not a point, but it's not cursive. Remember up here we said it had to be cursive, like a cursive, a small capital letter. So let's put a weird looking M. You remember how to do M's cursive? Probably not. Anyway, so that's an M. And so now I can name that line M if I wanted to. Okay, so it says name 4 points. Well, M is not a point, so it's A, C, B, and D, right? So A, C, B, and D. And I separate them here because they're points. If it was a plane, I would not put commas in between them, right? Okay. Name 3 lines. Well, there's AB. Okay, put the arrows on it. And then here's DC or CD, whichever. I'll say CD to say it backwards, what the heck. Okay, comma, comma. And then this is the third line, right, which is line M. Okay, now we can name this plane, right? Have to use 3 letters that are not in a row, not in a straight line. Okay, that's 1, 2, and 3. So that would be plane A, B, C is good enough. I could have said ABD or AB or ACB, whatever. Okay, and then name the horizontal line. Well, we already did that once. Let's do it again. Line M. Okay, so now let's go to the next page. All right. More vocabulary. First day is vocabulary intensive. Collinear points. We've already talked about them. Collinear points are points that are in a straight line. Okay, collinear points. Keyword is line, not ear. Okay, so A, B, and what are collinear? Yeah, C. A, B, and C are collinear. They're on a straight line. Okay, A, B, and what are non-collinear or not collinear would be D. Okay, A, B, and D. So you would call them non-collinear points. Okay, and coplanar points are different. They're points that are in the plane. Okay, So if I make a bunch of dots on this sheet of paper, all of these dots are coplanar to this paper plane, okay? If I drew a line that was on the paper, it would be coplanar to this paper plane. I'll be right back. Be right back. I'm coming. Here we go. All right. So what I've got here, there's somebody singing up here. Okay. Now this line right here, going through here, look at this, is not coplanar. But if it was laying in the plane, it would be fine. If it was dots on the plane, it would be fine. But it has to completely be within the plane to be coplanar. Okay? So A, B, C, and D are coplanar. They're all in this top flat part. Okay? A, B, C, and whichever point you want to pick down here, like G, are non-coplanar. They're singing. It must be the choir. Okay, so a segment is simple. It has endpoints. Okay, like this is segment go. Okay, so go, and then the way you name it is just to say GO, and you put the segment. You can put little endpoints on it, or you can just leave it like this. Just don't put arrows. Okay, if you want to, you could write it backwards. Okay, either one of those would work for segment go. Okay, next, let's do array. Okay, array starts from somewhere and then shoots off in another direction, so they add a point. Like if this was Mr. whatever, okay, so we would name this one always goes first, okay, no matter which way this is pointing. The one where it originates is where you start and put it first, and then you put the second one, and then the arrow always goes to the right. Even though this thing could be pointed this way, M and then an R, right? It's still this. It's still Mr., okay, to the right. So you start from here, go that way, but you start with M and you go this way, and the R, you go through the R and you always point to the right, okay? All right, opposite rays is when you have two rays that are going two different directions, and basically it creates a line, okay? So opposite rays is a line, okay? This ray that's going this way is named what? Well, you always start with the B, then you put the A, and then it always goes to the right, okay? This ray that's going this way, right, is BC, and it's always going to the right, okay? So you start from here, and then go to the right. Opposite rays. Okay, points P, T, and M, are they collinear? P, T, and M? No way. No. Okay? They're not collinear. Why? Because they're not in a line or a straight line. And this will be confusing. I ask if A, F, and B are coplanar. Okay? Here's A, and here's F, and here's B. Now, I didn't ask you the question about whether it was in the flat plane like this or if it was the standing up plane like this. I didn't ask that. I just asked you if those 3 points are coplanar. Because if you look at this, A and F is in this flat plane, right? And B's not, okay? And then B is in the vertical plane, but it's not in the flat plane. So it seems like they're not coplanar, but yes, they are. And you know why? Because any 3 points are always coplanar. Always coplanar. Okay? If I pick 3 points in the world, okay, I pick this one, and then this one sitting up like this, then I've got a plane that can go through it just like that. Chop. There's a plane. I could put my other point way over here, and I'd have a plane that was going uphill like this toward those 3. So any 3 points I pick, I've got a plane. Point, 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 I've got a plane. There's tons of planes that you can have, okay? So any 3 points is always going to form a plane, all right? The last page, just a few concepts, okay? Through any 2 points, there's exactly one line, okay? There's only one line that can go through 2 points, right? Okay? Intersections, okay? Intersections. A set of points that are shared by 2 lines or planes, okay? Now, if you have 2 lines intersecting, then what is the intersection there? What is that? That's a point, okay? So if I have intersecting lines, then its intersection is going to be a point. if you have two planes that intersect, then they intersect in exactly one line. So if like you had a wall and a ceiling and you look up there, and say you've got, I don't know if I can draw this. Okay, say you've got a wall and then the ceiling's coming this way. Okay, then this part right here, which, you know, that should be dotted, I guess. Anyway, this right here is a line. Okay, and that is the intersection. Like, look up at your wall, right? Well, let me move this here. Anyway, look up at your ceiling and see this line that's cutting across. This is the top, right? And this is the bottom. Okay, so the intersection of two planes is a line. Make sense? And then the last one here. Okay, what is that dotted line? That dotted line, I don't know if I can get you to see it here. Basically, the picture is this, okay? To where the top part of this line is the top part of the pencil, right? Let me make it a little longer this way, okay? So that is this part right here. Then all of a sudden it disappears and you can't see it behind the plane. That is the dotted line, okay? And then all of a sudden you can see it again, okay? You can see the little pencil down here. That's this part here. So it's a two-dimensional surface, so whenever you see the dotted line, it's telling you that this is sticking through instead of laying in it. If it was laying in it, would be a total solid line, okay? But it's sticking through. Does it make sense? So what is the intersection of a line and a plane? Well, it's simply point T. It's that point. So intersection of a plane and a line like that would be a point. Okay, all right. Have a good one. Bye.